All right, we've done some stuff with scientific notation. We've talked about how to convert in and out. We've talked about the two parts that make up scientific notation. Now we're going to talk about multiplying and dividing numbers written in scientific notation. Um, Typically, a lot of the examples that you'll see with this, if we're talking about a context, would be, things out in space would be huge, or little tiny little particles, little atoms, or how many atoms of something are in, a bigger container or something like that. But atoms are so small that they end up being a really small number, or there end up being a ton of them in there. So sometimes we need to multiply two numbers that are in scientific notation or divide them, depending on the context. And there's kind of a nice little three-step process that I'll outline for you. I'll try and color code it too. So step one is to multiply or divide the front numbers. Okay, this is what I mean by the front numbers. Right here, right here, right here, right there. All right. Then you add or subtract the exponents. So we got a 10 to the 6th, we got a 10 to the 3rd, we got a 10 to the negative 1, and a 10 to the 3rd. And that add or subtract depends on if this is a multiplication problem or a division problem. Okay. In this case, it's multiplication, so we would add. Then the last part is check to see if your answer is still in scientific notation. If not, convert it. Sometimes what you end up with is a number out in front there that's just too much, like too high. Or if we're dividing, it could be too small. And we'll see an example of that on number 2 over here. So let's go through each one of these. Number 1, my first step is to multiply or divide the front numbers. This is a multiplication problem, so I'm going to multiply 8.7 times 1.3. That gives me 11.31. Then I have a times 10, and I have 6 and 3. Step 2 says to add or subtract the exponents. Since it's a multiplication problem, I'm going to add them. So that gives me 11.31 times 10 to the 9th. Okay, and I've done steps 1 and 2. Step 3 says to check to see if your answer is still in scientific notation. I want you to look at this for a second. That part is not between 1 and 10. Okay, so what we're going to need to do is now convert this and move the decimal one spot right there. Okay, so this is going to be a 1.131. And I moved the decimal point one spot. And since this was a relatively large number, that means that I'm adding 1 to the exponent. You can also think about this as a balancing act. Okay, I made from here to here, this got smaller. So to balance that out, from here to here, this part has to get bigger. Alright, this got smaller by 1 decimal spot, so this gets bigger by 1 exponent. Alright, it's kind of a balance. They have to equal each other out. Alright. In this second one over here, I'm going to do step 1, which is multiply or divide the front numbers. So I'm going to do 8.3 times 9.9, and that gives me 82.17. And some of you already see what the problem is going to be. Then I have a times 10 to the negative 1 plus 3. So that's 82.17 times 10 to the positive 2. And now I need to, step 3, check to see if that's in scientific notation. It's not even close. 82 is way bigger than 10. So I'm going to need to move this decimal one spot to give me 8.217. Because of that, I made it smaller. So I know that this exponent has to get bigger to balance out, and that makes that a 3. Okay? So now we're going to do a couple of division examples. The only difference here is I'm going to do the same steps, but just divide numbers and subtract exponents. So I'm going to start with 5 and 3.9, and because this is a division problem, I'm going to divide them. So 5 divided by 3.9 gives me 1.282, we'll call it. It's a long decimal, but we'll just leave it at that. And then times 10 to the negative 2 minus 6. Because this is division, I subtract the exponents. So that gives me 1.282 times 10 to the negative 8. If you look at step 3, it says, check to see if your answer is still in scientific notation. It is, in this case. This is between 1 and 10. This is a 10. This is some sort of integer. Okay, so we're okay. That's actually done. That's the complete answer. You don't need to do anything else. In the next one, we got a 6.1 and a 5. I'm going to divide those. Gives me 1.22. And then it's a times 10 to the 1 minus 6. So that's a 1.22 times 10 to the negative 5th. And again, it's in scientific notation. There's a number between 1 and 10. There's a 10 and an exponent. So I am done.